This video is part of a series on formulae. Formulae have been met before in volume videos and area videos. Some of the formulae are shown in the screen. These are for solids and it's working out the volume of the solid. All of them have V equals because you're working out the volume. So we say volume is the subject of the formula because the formula is telling you how to work out the volume. If you want to turn these formulae around to, say, work out the radius or the height, then that's a change of subject of the formula. We're transposing the formula, turning them around. So take, for example, the cone volume. V equals a third pi r squared h. So there it is there. V is the subject of the formula. If I want to get what h equals, I want to turn the formula around to get h equals, I would get h equals 3v over pi r squared. This is telling you how to work out the height given the volume and the radius. So h equals means h is the subject of the formula. From being v equals, it's become h equals. So it's changed from the subject being v to the subject being h. So that's what we mean by change of subject. So this video is about how to turn these formulae around to change the subject of the formula. It will follow the rules for equations, which we'll go over. If we wanted the radius here, r would equal the square root of this fraction, 3v over pi h. So how to turn from this formula here in black into either one of these two ones in red is about changing the subject of the formula. So rules for equations apply. So as a reminder of these, an x here is an unknown in the equation, so you have to solve for x. It says x plus 3 equals 7. Equation's balanced. The left hand side and the right hand side have been made equal. So whatever you do to the left to keep it equal, you've got to do the same to the right. So here, for example, if I take 3 off each side, I've kept the equation balanced. Take 3 off the left, take 3 off the right. The reason to take 3 off the left is to get rid of this plus 3 and isolate the x. On the right, it gives you 7 minus 3. So we know 4 plus 3 makes 7. We know 7 minus 3 is 4. But we're about to replace these with letters. So we want to follow the rules for equations through with letters. Instead of saying 3 and 7, it's A and B. So when this says plus A, adding in A, we subtract A from each side. And on the left, adding A and subtracting A cancels out to be 0. And we get x on its own. So this is just same as in the equations. Equations, it was all numbers. Formula, it will be numbers and letters. This said plus A here. And it became on the other side minus A. So some remember this is change side, change sign. It was plus A here, it became minus A on the other side. It's add A, it became the reverse process, subtract A. Just like plus 3 became minus 3. Now this says x subtract 3 equals 7. So if I add 3 into each side, keeping the equation balanced, on the left it simplifies to x. On the right I've got 7 plus 3. So that's add 3 to both sides, gets rid of this minus 3 here, and becomes a plus 3 on the other side. Here, that says x minus a. Add a to both sides. On the left, minus a and plus a cancel out, and it leaves behind x equals b plus a. Or could be remembered as this says subtract a. So on the other side, I add a. So these are just the rules for equations, but we're using letters. So there was the results. Plus a became minus a. Adding a became subtract a. Subtracting a became add a. So these are the reverse processes. Add becomes subtract. Subtract becomes add. Now it's really that you're taking a off each side and you're adding a into each side. But it's easily remembered that way. Multiply and divide. So 3 times x is 6. Divide both sides by 3 and that'll give you 1x on the left. So equations kept balanced. We did the same thing to each side, division by 3. Apply that to letters. If it says ax equals b, divide both sides by a. So it gives you 1x on the left. And there it is. multiplication by x here, sorry, multiplication of x by a here, so that's a times x. So multiplication by a became division by a. We'd normally write that as a fraction b over a. Division by 3 here, that would normally be written x over 3, the fraction x over 3. Multiply both sides by 3, divide by 3, multiply 3 becomes 1, gives us a 1x. Multiply both sides by 3, x is 6 times 3. Apply that with letters, division by a, multiply both sides by a. So divide by a, multiply by a, that becomes 1. Result, x is b times a. So x divided by a, which we'd write usually is x over a, becomes multiplying by a. So multiplying by a became division by a, division by a became multiplying by a. Say, usually write them as fractions, so this is a multiplying x. So the other side we divide by a, so we write it as a fraction b over a. Here, dividing the left by a, so we multiply the right by a. So division became multiplication. So nice simple rules. Multiply becomes divide, divide becomes multiply. Division is usually the bottom line of a fraction. Finally, powers and roots. So if we're told x squared is 9, we know positive and negative 3 squared to give you 9. But doing the same thing to both sides, if I square root both sides, square root the x squared, square root the 9, square root x squared, you get x. So x is square root 9. Notice, squaring, x squared here, that red 2 becomes square rooting, the red square root sign. Squaring became square rooting. Apply that to letters, x squared is a, square root both sides, x equals square root a. Squaring became square rooting. It says square root x equals 9. Do the same thing to each side, square both sides. So you square square root x, you're going to get x. Result, x is 9 squared. Square rooting became squaring. There it is with letters. So square root x gives you a, square both sides. Square root x squared is x. And then we've got square rooting has become squaring. Here's the rules. Square root, squaring in the left, square root in the right. Square root in the left, square in the right. So these are inverse processes. Again, they're easily remembered. They're summarised here as adding a, other side subtract a. Subtract a, other side add a. Multiplication division, multiplying by a here, other side you divide by a, so it's the bottom line of a fraction. Here it's in the left, division by a, it's in the bottom line of a fraction. Other side, multiply by a. For powers and roots, squaring on the left, so you square root on the right. Square rooting on the left, square on the right. Now all these came really from the same process. This is really just take a off each side, add a into each side, divide both sides by a, multiply both sides by a, square root both sides, square both sides. So you're doing the same to the left as to the right, but these simple rules can be memorised and easily used. So that's what you're using to change of the subject. But you've also got to watch the order in which you do things. So when you solve an equation like 2x plus 3 equals 12, to get to the x you take the 3 off first and then you divide by the 2. You've got to do things in the correct order. Same with change of subject. So here's subject f, f equals. We want to change the subject to r, want to get to r. So you've got to do things in the correct order here. So think if you put a number in for r, like if r became 5, you would square it first to get 25, then you'd times it by 3, then you'd add in whatever p is. So when you put a number in for r, think what you do first, you square. R becomes r squared. Next thing you do is you multiply by 3. So the r squared get multiplied by 3 to give you 3r squared, and then you added in the p. That's the order in which you did things. Put a number in for r, you square it, multiply it by 3 and add p. First thing, second thing, third thing. and it gave you 3r squared plus p, which was what f equaled. So 3r squared plus p is f. So what you want to do is reverse all these things. When it says add p, take off p. When it says multiply with 3, divide by p, with 3, sorry. It says square root. So you not only do the inverse process, adding becomes subtracting, multiply becomes dividing, squaring becomes square rooting, but you got to do it in reverse order. This was first, then second, then third. So you go back, third, second, first. So you work your way backwards doing the reverse. Take off p, that's now f minus p, divide by 3. Now all of f minus p divided by 3, and then you square root. So notice add became subtract, multiply became divide, square became square rooting, but also this was first thing, second thing, third thing. So we work back third thing, second thing, first thing. You do the inverse process in reverse order. R is the square root of the fraction f minus p over 3. So to set out the working, this says add p. You take p off each side here. So there we go. You take p off the right, you take p off the left. Adding p becomes subtracting p. That was that bit. Multiplying by 3 becomes dividing by 3. So all of f minus p is in the top line divided by 3. So that was that stage. And then to get rid of this squaring, you square root. You square root the whole of the other side. And that's it done. It's just we usually write r equals. So just flipped it around to write r equals. So there were 3 stages. It was reversing these processes here in blue, but you had to do it in reverse order. Here's a second example. Got to get the subject to r. So think if you put a number in for r, say r was 4, you then square root it. Then you take off whatever n is, get the answer and divide it by d. So first put in the number for r, you would square root it. Then you'd take n off it. When you get the answer, you'd then divide it by d. And it would give you this root r minus n all over d, which is what w is. There it is, that's what w is. So work it backwards. Division becomes multiplying, subtract becomes add, square rooting becomes squaring. So starting with w here, multiply by d, wd. Add in n. Take this wd plus n and square it. That's it bracketed because it's all getting squared. R is equal to, in brackets, wd plus n all squared. So to show the working, what we're doing first is getting rid of this d in the bottom line. That's the first bit, you multiply by d. So multiply by d, wd equals root r minus n. That's the first bit, the wd bit. Get rid of this minus n, add in n to both sides. That's what's happening here. So it's wd plus n on the left, minus n became adding n. And to get rid of the square rooting, we square both sides. So this gets bracketed because the whole thing gets squared, and that's how it's got r. Usually write r equals, that's it done. So you've got to do the inverse process in reverse order. A couple of difficulties can come up. This is cases here. Change the subject to r. It's in brackets, so break the brackets up. A times v and a times ar, giving you a squared r. Complication is, I'm after r, trying to get the subject to r, but it's got this minus sign in front, and that's a real nuisance. So don't want to isolate negative r, I want a positive r. So the best thing to do in these cases is simply, this says subtract a squared r, so add a squared r to both sides. You add a squared r to the left and the right, and it cancels out the one on the right. Or if you think minus a squared r, change sign, became plus a squared r. We've now got a positive sign in front of the r term, which is what we want. So you take g away from each side. Now we've got a squared r. You want rid of the a squared, divide both sides by a squared. So that's why the whole of the right hand side is all over a squared. And when you write that, you've always got to make it clear you know the whole top line is on the fraction. So that's the subject change there to r. It's got a complication of this negative in front of the r term. So the best thing to do is take that onto the other side so it becomes plus. This one, we want r, but it occurs in two places. So we want it in one place. First, to the right is a division by r, so best to get rid of the fraction, multiply both sides by r. We've now got no fractions to deal with. Get the r's onto the same side, so take this pi r over to the other side. So I'm taking pi r off the right, so I take pi r off the left. Or if you like, this is adding pi r, became subtracting pi r. R occurs twice, you can factorise. R's a common factor, r bracket h minus pi. We've now just got one single r. H minus pi in brackets, it's multiplying the r. So we divide both sides by h minus pi, and it becomes h minus pi in the bottom line. And that's it done. These are the two more difficult cases. So that's change of subject. There's a worksheet, and essentially notes. If you click the link in the description, you can get access to the worksheet here. It's got dozens and dozens of examples to practice on. So it's 2 pages, and then it's got 2 pages with all the answers. They start off simple, just a one move, and then it just gradually brings in a wee bit more. It's difficult as you go through, more difficult as you go through. It brings in little complications like a negative sign in front of the letter that you're after, and then the next one brings in fractions and divisions. So what you're doing is you're multiplying both sides first to get rid of the fractions, and some have brackets to get broken up. They gradually get more difficult through the question, and then the more stages in question 3 get more difficult, and so on. Eventually in questions 4 and 5, so on, like in 5 you get factorising for the letter. So they gradually get more difficult through the questions, and the questions get more difficult as you go through the sheet, and at the end there's just mixed examples of quite difficult ones. But they've all got the answers. Lots to practice on, starting off simple and getting quite hard. So you might find, for example, towards the end of even one question you get stuck at them. The next question will start off a bit easier and work through and get more difficult. So that's changing the subject of a formula. The examples you've seen are on set of notes, just giving you the basic rules and the 4 examples. Hope you found the video useful.